This is RSA 2017, and you predicted that we were going to need machine learning and AI many years ago. What's the story?
You know, I'm surprised someone actually remembers my keynote from like 6 or 7 years ago, but Alan Turing was actually the subject of the conference that year, and it was about thinking machines. And I spoke for the need to have a form of thinking security, which has led to artificial intelligence. And I'm pleased to say we've started to make remarkable progress on that front. Because at some point, as I said in the keynote and subsequent keynotes, the attacker is going to do something anomalous. And if we have enough data and we can process it fast enough, then we can spot that signal in the noise that an attack is underway and not only detect it, but stop it cold. And a company that I'm proud to be associated with, Cylance, is doing just that. They have an incredible machine learning algorithm that can detect a virus before it has an opportunity to execute on your machine. So this is just the beginning of a new wave of technology and a new way of doing security. A platform for security that will scale and finally give us the opportunity to stay ahead of our adversaries.
One example that was given to me was the issue of fraud detection that banks do all the time, and they've been doing this for a long time. What can we learn, the community, from what the financial industry has been doing with fraud detection?
Well, actually, what we're doing with companies like Cylance is far more sophisticated than the algorithms that are used to spot fraud in banking transactions. So it's basically just the next generation capability of what banks have been doing for a number of years.
Can you give me a little more detail of that? What does that mean, the next generation? What are they actually doing?
Well, what we're talking about here is the complexity and the sophistication of the algorithms. Again, to use Cylance as an example, they're using billions of pieces of data to see how malware would actually behave versus a good executable in a file. So the big difference is the sheer amount of data that's being processed to create these machine learning algorithms.
And was it 6, 7 years ago when you were first talking about this, was this just not possible because the subject of big data was not a discussion back there and we could not process that kind of data, and today we can?
Well, yeah, it's really a combination. Big data is a combination. The ability to have big data applications is the ability of compute power, storage, and quite frankly, data science, the people that can take advantage of this capability to be able to create these kind of algorithms.